A new ecosystem full of unknown creatures has been discovered under the ocean floor. Beneath hydrothermal vents on the Pacific floor, scientists have found an incredibly rich ecosystem. Digging up the seabed with a remote-controlled drone, researchers discovered a habitat full of never-before-seen life forms, strange species of invertebrates, snails and deep-dwelling octopuses. The previously unknown ecosystem was discovered as part of a research expedition carried out by the Schmidt Ocean Institute. The Sebastian underwater robot equipped with a robotic arm has been launched from the Falcor ship off the coast of Central America. He managed to remove the upper layers of the bottom near the hydrothermal vents at a depth of about 2,500 meters. There, an ecosystem unknown to science, full of peculiar animals and chemosynthesizing bacteria, awaited the researchers. Hydrothermal vents were first noticed in 1977 during the study of the East Pacific Ridge. They are a product of the Earth's geological activity. They can often be found in volcanically active places or where tectonic plates collide. The chimneys can reach a height of several meters and gush hot, mineral-rich water. Despite the extreme temperatures around hydrothermal vents, reaching as high as 360 degrees Celsius in some places, scientists have discovered thriving food chains filled with chemosynthetic bacteria, snails and crabs that draw energy from the nutrient-rich water coming out of the vents. But until now, no one has looked under these structures. As part of the mission, scientists used Sebastian's robotic arm to pull down the upper layers of the ocean floor, then placed bins over the resulting crevices and pits. When they checked them after a few days, they discovered a lot of strange creatures. Researchers indicate that they must have got into the containers from under the ocean floor. We've known about animals living on land in underground cavities for a long time, and animals living in sand and silt in the ocean, but this is the first time scientists have been looking for animals under hydrothermal vents, says Jyotika Varmani of the Schmidt Ocean Institute, who led the expedition. This is a truly remarkable discovery of a new ecosystem, hidden beneath another ecosystem, which provides new evidence that life can exist in amazing places. Our understanding of animal life near hydrothermal vents has greatly expanded with this discovery, says Monica Bright, an ecologist at the University of Vienna who was part of the expedition. There are two dynamic habitats. Animals that live above and below the surface around hydrothermal vents thrive together in harmony, depending on the fluid coming up from below and the oxygen in the seawater, he adds. Researchers have determined that some species can travel below the surface in a network of veins of hydrothermal vents filled with warm, nutrient-rich water, expanding their range. This may explain how some invertebrates colonize new environments. The discoveries made on each Schmidt Ocean Institute expedition highlight the urgency of fully exploring our oceans so that we know what exists in the deep sea, said Wendy Schmidt, president and co-founder of the Schmidt Ocean Institute. The discovery of new creatures, landscapes, and now a whole new ecosystem highlights how much we still have to discover in our ocean, and how important it is to protect what we don't yet know or understand. Scientists from the Schmidt Ocean Institute are to publish the description and results of the research later this year. In the meantime, I will continue my observations of this newly discovered and mysterious ecosystem. Chemotherapy may increase susceptibility to disease in future generations. Chemotherapy destroys cancer cells and prevents them from multiplying, but it has many side effects. Scientists have just discovered another. It turns out that the commonly used chemotherapeutic drug can cause many health problems to the children and grandchildren of the patients whose lives it saved. Researchers at Washington State University have determined that the side effects of a phosphamide, which is used as a chemotherapeutic agent, can manifest themselves in future generations. This agent is a derivative of nitrogen mustard, i.e. a poisonous combat agent. And because it affects the entire body, it also affects the reproductive system. Our findings suggest that if a patient receives chemotherapy and then has children, the grandchildren and even great-grandchildren may have an increased susceptibility to the disease due to their ancestors' exposure to chemotherapy, said Michael Skinner, a biologist at Washington State University. The description and results of the research were published in the journal, iScience. Washington scientists point out that this is not about chemotherapy in general, but about a specific drug used during it, ifosfamide. Studies in rats have shown that those given it during puberty had an increased susceptibility to disease in their offspring. Even mice's great-grandchildren are at risk. The researchers found this by crossing simulated treatment male rats with untreated female rats. However, in the next generation, they were crossed again with individuals that had no contact with them. In the case of the rats studied, the transfer of this risk to their offspring could be explained by the fact that their father's sperm was exposed. But how do you explain the increased risk for future generations? Scientists had to dig deeper here, and the answer was the epigenome. These DNA-independent molecular processes are able to influence gene expression, including turning them on or off. Previous studies have shown that exposure to toxic substances can cause epigenetic changes that can be passed on to the next generation through sperm and egg cells. Such epigenetic changes were found in 2 successive generations of rats on which the chemotherapeutic agent was tested. The conducted studies indicate that among the diseases whose risk of occurrence is increased by ifosfamide, there are diseases of the kidneys and testicles. Genetically affected individuals may also mature later. They may also experience decreased levels of anxiety, which in turn may interfere with their ability to make appropriate risk assessments. How should currently treated patients behave? First of all, they should not give up chemotherapy. Researchers at WSU recommend special precautions for those planning to have children soon. They freeze their sperm or eggs before starting chemotherapy. In this way, their offspring will not be exposed to the potential adverse effects of chemotherapy on their health. The results obtained by the researchers are unique because they are the first to go beyond predicting the possibility of the disease at a later stage of life by the sick person himself. Although the results of studies confirming this possibility have also been published. In the current situation, it will be crucial to conduct studies on humans this time, so that potentially vulnerable patients can be identified. In this way, it would be possible to warn them about the diseases that may develop in themselves and what tendencies they may or may have passed on to their offspring.